maybe calculus. What I would do on developer is finish writing the product rule and then take the integral of both sides. Of course, at this point, you have no idea why you're doing this, but you're working toward the proof of what we're going to be using today, the formula we're going to be using today. So what's the product rule?
D right.
Left, D right. That's right. It is dV. You would normally write right, but just left, right, D left. Okay. Any questions thus far? Integrate both sides. What happens to the integral of a derivative? With some rearranging, for whatever weird reason we want to rearrange, we can get a formula for the integral of u times dv. So what this is a way to undo a product rule in an integral. Now this is the proof. Of course, this is very unuseful to you at this point, but this is the formula we're going to be using today. The integral of u dv equals u times v minus the integral of v du. In a conference that I went to one time, the guy that taught it had his kids memorize this by saying ultraviolet voodoo. I don't know that that's helpful, but maybe it can help you remember the u times v minus the integral of v du. Anyway, this is a formula you will need to memorize. So today what we're going to be looking at is integrating by parts. That's what this is called, integration by parts. It's going to feel very algebraic. Essentially, it's a formula you follow to integrate two things multiplied together. Integration by parts is used when you have a product that you can't simplify. What I mean by that is never use integration by parts to do x squared times x cubed. Why not? That is x to the fifth. Integrate by using the power rule. So don't use integration by parts if you have another option. If use substitution works, use substitution, which we've learned ways to find out if use substitution works or not. But if you look at the examples I have up there, x e to the x. Would use substitution work on that? X times e to the x. X times sine of x. X times natural log of x. You see how all of those are problematic. So we're going to use this formula to anti-differentiate. Now I'll show you how it works. Our example that we're going to use is x times cosine of x. So I want to find the antiderivative of x times cosine of x. We're going to choose a u and a dv. Essentially, it's a little similar to substitution, but you're going to pick two parts. You're going to pick a u and a dv. So label your pieces. You want to choose u so that when you take the derivative of it, it goes away. Example, natural log. What's the derivative of natural log? 1 over x. Would you agree that would very much simplify an integral if you could change natural log into 1 over x? So we're going to use the function that can be broken down the easiest. This is another thing I got somewhere at a conference. When I took Cal 2, we just figured out the best one by thinking about it. But this is a good list of where you would start by choosing your u. Log is the best choice for you if it's an option. An inverse function is a good choice for you if it's an option. An algebraic function, what that means is a polynomial. Polynomial is a good choice for you. Trig and exponential functions are not good choices for you. So they would be your last choice. Now, I'm not saying sometimes we won't choose them, but they would be your last choice. If you could choose one of the top three, we would do that first, and then we would do the other ones if necessary. And you'll see why when we work this problem. So what we're going to do, we're going to go through that list. There's not a logarithm, there's not an inverse function. So the first thing I see is the algebraic piece of x. So I'm going to let u equal x. And so then dv is going to be the other piece. What other piece? So what's the rest of the function besides the x? Cosine of x dx. So v is everything u is not. I'm going to differentiate u and I'm going to integrate v, dv, to get v and u. So I'm going to differentiate, or du, sorry. I'm going to differentiate u and I'm going to integrate the dv. So what is the derivative of u? 1 dx. And I'm going to integrate dv. What is the integral of cosine? Sine. So now I have an expression for v and u. So remember the integral of u dv is equal to u times v. So what would u times v be? Any questions about that part? So I just pulled the u and the v down, so following that formula, u times v minus the integral of v du. What's my v? Sine of x. And what is du? What is du? Just 1 dx. Everyone agree? Is this integral possible? So I took an integral that was impossible with current methods and used this formula to rewrite it with an integral that is now possible. So that's how integration by parts works. Now I'm going to integrate that. The x sine of x is done. I just leave it as x sine of x. What is the integral of sine of x? Would be plus cosine of x. Does everyone know why it's plus cosine? Negative, negative. And then, of course, what am I always going to write on an indefinite integral? Really quick, pull out your TI-89. Subtract the integral of x times cosine of x dx. Or just for fun. What I am giving you right now is a way to check your homework. I'm giving you a way to check your homework. If you do your homework this way, what will happen on the test? You will fail.
So we're just doing x cosine.
Yeah, the integral of x cosine of x dx. You will probably need to put a multiplication symbol in between the x and the cosine of x, so that your calculator knows it's x times cosine of x and not 4 variables x, c, o, s, and x with them. Has everyone figured out how to use the integral button? Okay, go to your home screen. Type F3. Home screen, type F3. Type sine, take x times cosine of x, comma x, and close your parentheses. tells you how to work the TI-89, right?
Yeah.
Use those. What did you get? So that, right? You need to put a multiplication symbol between the x and the cosine of x. Otherwise, it thinks the word x cosine is some kind of weird variable.
So whenever I do it, it still says 2 0.
Did you put comma x?
Oh.
Why?
You still just have to have multiplication between variables. Always, anytime you write, in general, anytime you write two letters next to each other on the TI-89, if you mean multiplication, you've got to write multiplication. The reason it does that is you could type velocity in as a variable, and it would work the word velocity as a variable. And so you need to let it know.
What do you mean?
After you type the x times cosine of x, you have to put comma n.
Oh.
To tell it what variable you're using. Okay, so that is integration by parts. The rest of today will be more examples of integration by parts. Okay. Just like quick mental note, I kind of like my brain space, and I probably would not memorize that word liate. That's what the guy who I got that from confused. However, if you aren't real good at deciding what to make, remember on U substitution, those of you who aren't really good at picking U, you need to memorize that. Because it'll be kind of the same thought process. Those of you who are good at reasoning through what you to pick, you would be fine without memorizing it. Do you have something stored for that? Don't ever store anything as text. Use any other variable, A, B, C, D, E, F, G. What I did is open F6, which is clean up, and cleared A to Z. But leave your, did everyone hear that? TI-89 troubleshooting. If it's giving you a number when it should be giving you a variable, you've accidentally stored something as x, always avoid storing things as x in your TI-89. If you ever accidentally do, you go to F6, which is second F1, and clear A to Z, and you can clean up. Okay, let's look at this next one. Now, I want you to think for a moment. What would be a wise choice for you?
One higher up on the list.
The one higher up on the list, X. And let's think about why. If I choose X to be U, then what's D going to be? Just 1, which is good news because that means I can work that integral because 1 is, it's going to be e to 3x times 1. Maybe some constant involved, but other than that. So what does that mean dv is? Everything else. I will tell you there is what some professors will call a shortcut to integration by parts, and they call it tabular integration. I don't like shortcuts because I feel like kids don't know how to do them long term. And a lot of the students that I've had go on to college come back and ask me integration by parts questions. And they just can't wrap their mind around what that shortcut is. But your college professor, if you go to U of A doesn't even teach you the real way to do integration by parts. It kind of skips the shortcut, which is really confusing. It's a nice little shortcut. It's actually shown in your textbook. If any of you are interested in seeing it, go read it. It's just a little way to shortcut. It is integration by parts. but it's just a shortcut. In general, I'm not a big fan of shortcuts because you know them for the test, but you usually don't remember them for the AP exam, which is bad news. So that's why I'm not teaching that shortcut. But I do want you to be aware that it exists. So if you're interested, it's pretty easy to follow once you really understand integration by parts. So maybe tomorrow we might look at one with the shortcut so you can see how it works. I prefer that you understand it first, and then we can talk about shortcuts. Any questions so far? Okay. To finish the formula, I need B and I need du, right? So how do I get du, first of all? And how do I get B? What's the integral of e to the 3x? Actually takes a little bit of work.
130 to 3x.
It would be 130 to the 3x. Why?
U substitution.
Okay, you have to either do a U substitution or think about doing a U substitution, right? Because what's the derivative of e to the 3x? 3 times e to the 3x. So you have to undo that 3. Now, some of you are getting good enough at integration, because you've been practicing, that you can undo that in your head without doing a U substitution. You may need to go do a side note and do a U substitution. I would make it a side note, that way you don't get your two different U's confused. You might even call that U something else, some other letter. Du would be 3 dx. So 1/3 du would be dx, and that's where you see the 1/3 coming out of that integral. So at some point you've got to get that 1/3 in there. I've noticed y'all messing that up on E and on the ones that are natural logs. So 1/3, 1/3 minus x, or 1/2 minus x. Y'all just call it natural log of 2 minus x. Remember that negative 1's going to come out when you take the derivative, so be careful about that. I think that was on last AP exam where you had to do that, so just be careful about that. Even if you don't do a U substitution, think about what you would have to do, how that would turn out. So, my integral is equal to u v. And again, if you need to remember which one comes first and what, that ultraviolet voodoo is a pretty cute little way to remember that. But, or you can just memorize the formula. V du. The voodoo, you see how it works. V is 1/3 e to the 3x times 1 dx. You can move the 1/3 out of the way if you need to. Does everyone know what I mean by that? You can move that in front. We've already thought about this integral once today, right? Minus 1/9? Yes. Any questions about why that's 1/9? And don't forget the plus c. Any questions about that? So, when you're doing your homework tonight, do I expect to see work? Yes, otherwise I will assume you put it in your TI-89. But, can you check them all in your TI-89 until you get the hang of this, until you're comfortable? Oh, we've got one more on this page, don't we? Okay, let's look at the next one. This one is a definite integral. So we haven't done one with limits on the end, so we're going to do one with limits on the end. integral setup. See if you can get the part without the 0 to 2 pi, or pi over 2. We'll talk about the 0 pi over 2 once you get the antiderivative. I'm going to go ahead and pass this homework out. The printer did not work on the first couple pages of this worksheet, so I am reprinting it. You'll get it tomorrow. So all of the parts you can't see, just skip them for now. You'll get those as a nice, pretty copy tomorrow. So this page is really your homework for tonight. But you can kind of see the homework you're getting for tomorrow night. They are AP. I pulled the real AP problems that have been asked about integration by parts. So you can, just like I've always done in the past. So we have printer issues. Some of them you can see. So if you wanted to get a head start on tomorrow's homework, it's those multiple choice problems. So you're welcome. But these 6 problems on the front are the ones that you do have to do tonight. The other problems, again, if you can read it, you're welcome to go ahead and do it. That's what you're getting tomorrow. Yes, because they don't exist on the AP test. So I went through, I've been working, I've been trying, helping out. So I went through and pulled all of the integration by parts, multiple choice, and then open response, as always, we'll do a packet of it. So just like every other chapter, you'll see multiple choice in the daily assignments, and then you'll see open response in the AP packet. There aren't very many open response that involve integration by parts. I think there was one. Most of the integration by parts fall on which is kind of nice. So to me, integration by parts is not terrible. A little strange.
So we just put the back part.
Yeah, just the back part for now, but again, if you can see it and want to, you know, anything you can see, you're going to get that worksheet in a clear copy tomorrow. It was pretty awful. Some of them you could see, but some were completely illegible, so.
I can't see the picture.
Yeah, I can't see number 2 either. But you can see number 1, so you could do, you know, and like I said, anything you do now.
You can see all of them except for number 2.
Okay, you can see
Number 2 and this.
Yeah. So anyway, welcome to, that's your homework. Note that does when I get your homework for tonight tomorrow. Do homework on it. So, we'll see how long it's going. I don't know. Here's one problem we haven't covered. We'll see if we get to it. Okay. So, are we ready? What did we call you? What did we call DP? And so over 2. Plug in the 0. I probably wouldn't show all this work if I were working on an AP test. Sine of 0 is 0. Everyone agree? Sine of 0 is 0, right? Cosine of, well, 0 times anything 0, so that whole red part's 0. Cosine of pi over 2 is
1,
0, isn't it? So the whole thing's 0. Oh wait, no. Plus 1. So it's the whole thing's 1. Yeah, you're going to do the same thing like you're doing from 0 to here and here. But there we go. It would never be different. So you can always, that's what I meant by you could stop and do it here. I wouldn't. I would just like do it all in, but you can do that. Okay. I may only do one of these. I'm going to try to get, and then we'll do the other one for, oh, I have some bookwork. I forgot. We have some bookwork.
Okay.
We have 2 minutes coursework.
Oh, okay.
Okay. X squared sine of x dx. Now, which one are we going to make cube? X squared. Does anyone see a problem with this problem? Why it's going to be slightly tougher? Use it twice. I'm going to use it twice. So this one's a yes. So, I agree, x squared is definitely algebraic. It always because what would happen with the sine function if you made it du? Sorry. Wouldn't it just always repeat? Go sine x, cosine x, sine x, cosine x, with negatives or positives, but so it's not going to get you anywhere with integration by parts. This one will eventually get you somewhere, but because it's x squared, it's going to take 2 repetitions of integration by parts before it goes. Did you say disgusting? It could be worse. At least it's just algebraic, though. It's disgusting, but not related rates disgusting. You don't have to set anything up, you just follow the rule. The algebra brain people in here probably like integration by parts. You just do it. No, it's fun, but I worried this is how hard to teaching integration by parts because I remember it being really easy. And sometimes that's dangerous. It's easy to make it help teach you something. Don't feel it okay so far? Where I remember Shell's big hard. So I was worried about it and I felt like something was going with it. Hey, any questions so far? Negative cosine of x. And here's the problem. V du minus the integral
X is not.
I did it with X. X squared negative cosine of X. Thank you. UV minus the integral. You're lost. You really are lost? Where?
I thought I got it, and you just erased it.
V times U minus. Cosine of X times 2x dx. Any questions so far? I can simplify that a little bit. Now, okay, if I change that to a plus and make that x cosine of x, rearrange. But why is this still a problem?
Because of X cosine of X.
The x cosine of x is not something I can just take the integral of. In fact, it turns out to be another very good integration by parts integral. So, yuck. We know. So, well, what do we do? Do it again. No. I'm going to rewrite the blue part. That's red.
So, other functions that we have here, we can discuss this.
No. The ones, if U substitution is an option, U substitution is easier. So this would not simplify anything. The only thing it would do that you couldn't do, you remember how I made you memorize X, or the natural log of X, antiderivative of natural log of X? That derivation comes from integration by parts. Because you can let U equal natural log of X, 1 dV, 1 dx, dV. But that's the only thing that integration by parts gives us from AP is that formula. Other than that, everything that you could do, U substitution, you would still want to do U substitution. Okay, so now I'm going to label in just this piece a U and a dV. I'm going to call it U1. AP wouldn't count off if you just used U again. Your college professor might. I'm going to call it U1 or U2 or something to designate that this is a different U and V from the first U and V that chose. What would be a good choice for you? X. And what would be a good choice for dV? Okay, any questions so far? Good so far? UV is X sine of X minus the integral of V du. Questions so far? Now, it is very important that you don't forget your first portion. That's the danger in something you had to do twice. It's forgetting the first part. What's the antiderivative of sine of X? Negative cosine, so it'll become positive 2 cosine of X. The 2 with the distributed piece. And what do I need to tack onto the end? tomorrow we'll do this example. We'll do 2 more examples. We'll be done tomorrow. Why is this one crazy hard? Neither one will ever go away, right? Turns out we can still do it. I'll show you how to do this one tomorrow. So if you come to one, everyone listen. If you come to one with either 2 trig functions or a trig function and an exponential, save it for tomorrow. Figure 12, even 17, and 18, and the worksheet all due Wednesday. 12, even 17, and 18 all due Wednesday. Tomorrow I have 2 problems to teach you, or the rest of the day will be a work day. One problem we'll do is bell ringer, the other problem I will have to show you. So remember, if you come to any that are trig function, e function,